Hey guys, today we're going to be looking at like fractions. We're actually going to combine lessons 2 and 3 of chapter 9. They're pretty similar, so I'm going to have you watch one video and then we'll do 2 days worth of work on them. Chapter 9 lesson 2 is on adding like fractions, and chapter 9 lesson 3 is on subtracting like fractions. So we're going to kind of do double today and see what we get. Alright, first I'm going to show you my lovely fraction pieces, and we're going to look at some vocabulary. We're looking at like fractions and determining whether they're the same or not. So if I show you these two pieces and tell you that they are like fractions, what could you maybe figure out about that? Now if I tell you these are not like fractions, they're unlike fractions, what does that tell you? Well, if we go back, these have the same denominator. I could even use 2 of them, so have 2 sixths and 1 sixth. They're still like fractions because they have the same denominators. Unlike fractions are going to be the ones that have a different denominator. So for right now, we're looking at all the same size piece. Okay, so we're going to start with a problem. We're going to start with 5 sixths plus 5 sixths. So I'm going to try to model using my fraction pieces. So first I have 3, 4, I'm going to try to hold them all in my hand, 5, which is almost a full piece, and that would represent this one right here. Next, I'm going to take another 5, 3, 4, 5 over here, and I'm going to add them together. So obviously I need one more piece to make my whole. Whoop. If you can kind of see that. And then I have a whole, so I'm going to go ahead and write that down. This equals 1 whole, but wait, oh, I have 4 more pieces left over. Because 6 of them made a whole, but then I have 4 left over. So, since they are 4 of the 6 pieces, I'm going to write 4 sixths. Now this would be my mixed number. I can also look at it as how many of the 5 6 pieces that I had. I actually had 10 sixths because I had 10 of the 6 pieces, but that's what we call an improper fraction. So we want to change it to say that it's 1 and 4 sixths. Now there's one more issue with this 1 and 4 sixths. It's that it can actually be reduced. Just like we've been simplifying fractions, we can actually simplify this. So what you would find would be that I can divide the top and the bottom both by 2 because they have that common factor. And then I would end up still with my whole number, but then I would have 2, and then 6 divided by 2 is 3. So to make it proper and to simplify it as much as possible, it would actually be 1 2/3. Okay? Now, if I don't use my fraction circles and I just look at the math here, what we're doing is we're keeping the same denominators. So we're going to keep our like fractions and bring that across. So I'm still using the 6th piece. And then I'm just going to add across the top. So I have 10 plus 5 equals 10, which got me the same exact thing. And then what I can say is, well, I know that 6 of these pieces are going to equal a whole, so I can divide this 10 up to be 6 and 4, because 6 plus 4 is still 10. And then that becomes, I mark these off and have my whole, but I have 4 ones left, so I have to have 4 sixths, which is the same thing, and then we just simplified again, so dividing the top and bottom by 2 to get 1 2/3. So it can work either way here. We can do it using our fraction circles, or we can do it using just our numbers up here. All right, let's look at another problem for addition. Let's look at 4/10 plus 2/10. I'm going to start by grabbing my fraction circles. So I'm going to start over here, and I have a 4 of these, and I have 2 of these. So if I put them all together, notice that my size of the piece didn't change. So my denominator is still going to be 10. And then I just added them together. So 1, 2, 3, 4, 5, 6. So I have 6 of them now. So it would be 6/10. Now 6/10 can be simplified. Let me show you. If I take out my 5th pieces, if you were to have your fraction circles and you started to compare, you could hold up your 6/10 just like this. And you could say, what's the same as this 6/10? And you could start laying your 5ths on top of it. There's 2/5. Whoop, as I lose it. And there's 3/5. So it fits perfectly on top of it. Back side is our tenths, top side. So we can see that it's actually the same as 3/5. So 4/10 plus 2/10 equals 6/10, or if we reduce it to 3/5. Let's look at the math behind this. I start off and I have my 4/10 plus my 2/10. So my denominators stay the same, giving me that 10. Then I add my top, so 4 plus 2 equals 6. And then to get from here to here, all I have to do is find the common factor. They're both can be divided by 2. So I have 6 divided by 2 is 3, and 10 divided by 2 is 5. So that's how I would find those like factors, and then this 3/5 would be my answer. All right, moving on to subtraction. It's pretty much the same. You're just looking at subtracting across the top. Let's start with 7/10 minus 3/10. Now if I was to pick up my tenths pieces again and grab them, here's 4, 5, 6, 7. The only difference here is that instead of adding more, I'm just taking away. So if I have 7/10, which is what I have right now, and I'm subtracting 3 of those, I just take 3 of these pieces away to get 4/10. So that would equal 4/10. Now again, I could look at this and I could say, well, this 4/10 could be reduced. I could actually lay my 5ths on top of it and it would be the exact same size. So what I want to do is I want to reduce it and I want to get 2/10. Or no, 2/5, sorry. I was looking at that 10. 2/5. All right, let's look at how I did this. 10 minus 10, I don't subtract, I leave the denominator the same, so I still have that 10. All I do is subtract the top. 7 minus 3 is 4, which got me my top number. And then I realized 4/10, that can be reduced. I can take both into 2. So I did 4 divided by 2 was 2, and 10 divided by 2 was 5 for my final answer of 2/5. Let's do one more problem before we go. Let's do 9/10 minus 3/10. Since they have like denominators, I literally can write it like this. I can say 9 minus 3 on top and 10 on the bottom, because my 10 is not going to stay the same. So all I have to do is do 9 minus 3, and I get my 6/10. Now 6/10, that's close to your final answer, but you've got to determine whether it can be simplified. So is there any common factors that they have other than 1? Let's see, they both have 2 in common. So we're going to divide the top and the bottom by 2 and end up with a final answer of 3/5. Same answer as before, crazy enough. All right, so the next 2 days we're going to be looking at adding our like factors and then subtracting our like factors.